Okay, we're looking at lessons 1 and 2 of the rationals unit. So textbook questions, page 317, looking at question 8. It says, write each rational expression in simplest form, state any non-permissible values for the variables. So just a reminder that non-permissible values, sometimes we'll call it non-permissible values. Sometimes we will say, what are the restrictions? Okay, so you'll see it asked in both ways. Non-permissible values, restrictions. Usually with restrictions, we say the variable is not equal to, and non-permissible, we just state the values. So in this case, simplest form, remember, you have to factor everything first, if you can. You can only divide out common factors. So for A, those are all factors. Those are monomials in the numerator and denominator. Okay, so really this is back to even before Math 10, junior high, in terms of power rules. Although I guess with the p's that's more Math 10. So you want to, 2 goes into 4 twice, into 6 3 times, and then r squared divided by r is r. So this is going to be 3r. And then notice here, p cubed and p to the 4th in the denominator. So there's more p's down in the denominator. So if you use your power rules for dividing, you subtract. You would get p to the -1, which really means there's a p in the denominator, so 2p. So you can show this as 3r squared p to the -1 over 2, but we always like to show with positive exponents, so that's why we do that. In terms of restrictions, you have to go back to the original, look for any variables that are factors. So r can't be 0 and p can't be 0. Okay, if you just look here, you're going to miss the r. Okay, so then b, we actually have to do some factoring. Okay, pretty straightforward factoring. So in the numerator, 3 is common, multiplied by x minus 2. In the denominator, 5 is common. And notice here that these aren't the same right now. So you might think, oh, there's x's and 2's and a minus. I can divide them out. Not quite. So what you could have done this in one step and factored out a -5 from here. Or from here, divide out a -1, which makes this -5. And then that's going to be -2 plus x. And we like to show the x first. Okay, so this, if I factor out the negative, I will have -2 plus x, and then I just rearrange it. So now I can divide out those common factors, and it's always best form to show the negative out front or with the 3. Okay, if you think about this as a dividing, positive divided by a negative is a negative answer. We just don't like to leave the negative in the denominator. Okay, and then C. So C is going to be b squared plus 2b minus 24 over 2b squared minus 72. Now, if you need to show your work for factoring, do it outside of the actual rational expression. So if you're not sure how to factor this, or if you use decomposition, do it outside. This one here, so in this case, it's a simple trinomial, so you're looking for two numbers that multiply to -24 and add to 2. So this, I don't need to show any work. That's going to be b's at the beginning, and that's going to be 6 and -4. So that's going to be plus 6 minus 4. Now the next one, I notice there's a 2 in common, so I'm going to factor out the 2, and so here, this is my work, just showing on the side. Now that can be factored again. That's going to be b plus 6 times b minus 6. It's a difference of squares. So now I put that back in to my rational expression, and then I divide out the common factors. So then I'll have b minus 4. You can remove the brackets because there's nothing else with it. Leave the brackets, obviously, in the denominator, and that's in simplest form. Even though it's factored, you don't have to expand that back. For rational expressions, you actually want to leave it in factored form. In terms of restrictions, you go back to this step, okay, in the denominator, and so b cannot be -6 or +6. Okay, so that's simplifying rational expressions. Question 8. And then question 13, looking for a mistake. So this is a common type of question, especially when you get to Math 30 and the diploma exam. They'll definitely have a question like this where you have to spot the error. One or more questions, actually. So Shelley incorrectly simplifies this rational expression. What is her error? So let's take a look at this. This is a difference of squares, so that factors correctly. Here, 2 is common, so that factors correctly. So she did her factoring correctly, and then you would divide out the common factors. So she did that part right, and then she stated it as g plus 1. That's the wrong part. This is the final answer here, okay? This 2 has to go into every term there. So basically you have to be able to factor out a 2 from the numerator in order to divide it with a 2 in the denominator, and you can't. So if you separate it, she would need a 2 there, g over 2 plus 1. So that's where she went wrong. Okay, so why she didn't divide both terms in the numerator by 2. But she didn't need to. Okay, you can leave it as that circled value. Okay, so the correct solution is this. All right, so that's question 13. Question 22, write a rational expression equivalent to this that has a denominator of 12. So here we want to show this an equivalent fraction. So that could be, you could have to multiply top and bottom by the same number or divide. In this case, if we need this to be 12, then we need to multiply. So really we're going to multiply here by 4. Okay, I'll just use a dot for multiplying. And so that means the numerator has to be multiplied by 4. Okay, same thing, top and bottom. So that means when we show this will be 4 times x minus 2. And then really that's the same. You could show it as 4x minus 8 over 12. Okay, either one of those. Denominator, so now here, so that was a, b, so we have x minus 2 over 3, and now we need a denominator of 3x minus 6. So you have to think about how to get 3x minus 6 from here. We can't just go x minus 6, x minus 6. Those aren't factors, right? So this, remember, is 3 times x minus 2. So factor that denominator. All right, so how do we get 3 times x minus 2 here? That means we need to multiply top and bottom by x minus 2. Okay, and I'll put brackets around that original numerator. So now our numerator is x minus 2. Notice how they're both the same. So it's really x minus 2 squared. If we were to show it, to show it sort of like an original rational expression expanded, that would be x squared minus 4x plus 4 over that 3x minus 6. Okay, so factored here. This isn't simplified. This is the simplified form, right? The original one. And so then oh, you know what? I just realized here. Numerator, that says numerator. Okay, so this isn't really B. This is a different question. Okay, so this is denominator of 3x minus 6. Okay, so let's do B, where it is numerator of 3x minus 6. 1x minus 2. Now that we've done that other one, this will be pretty straightforward. Okay, so now we want to factor that, which we already know because we did it just a minute ago. So 3 times x minus 2. So that's what we want to do. So notice here, this was x minus 2. That means we need to multiply this by 3. Okay, and you can show it in front or at the end, but it's multiplied. So that means the denominator here will be 9. Okay, so you can leave it like that, or you can show it in expanded 3x minus 6 over 9. Okay, so that's simplifying. All right, then if we look at multiplying and dividing, then here, write each product in simplest form. So question 2 would be A and C. So let's do A. So taking a look at this, you always want to factor first. Yeah, you can start dividing out some numbers in 36 and 144, but you can't divide, don't start dividing D's and 10s. You can't. You want to, the odd time it would work out to be okay, but you have to divide out a whole factor. And so if you want, if there's 2 terms anywhere, then put brackets around them. Right now I can't divide out those brackets. So I'm going to factor, this is a difference of squares, so that's going to be D plus 10 times D minus 10, or 144, times 36 over D plus 10. And as I said, I kind of put brackets to helps me look for common factors. So now that's really straightforward. The D plus 10s divide out. You can never divide out horizontally, only vertically and diagonally. Right? Common factors. And then check. 36, does it go into 144? So it goes in 4 times. So now our simplified, what do we have? So this is really a 1 there. So we just are left with D minus 10 in the numerator and 4 in the denominator. In terms of restrictions, you take a look back at your factored form. There's no variable there. There is here. So D cannot equal negative 10. Okay? Those are called restrictions, or negative 10 is the non-permissible value. All right, and then C. So lots to do here. I'm going to start factoring. So the numerator is a difference of squares. So that's going to be 2z plus 5, 2z minus 5. And denominator is a non-simple trinomial. So if you use decomposition or anything else, do your work on the side. So here I'm looking for 2 numbers that multiply to 40, 2 times 20, and add to negative 13. Okay, so 8 and 5 multiply to 40. They're both negative. They add to negative 13. So that helps me get my inside-outside. So the only way I can have my first values, 2 is a prime number, is 2z and z. So then my outside would have to be negative 4 in order to get negative 8, and my inside would be negative 5. Okay, and then multiplied by, nothing to factor in the numerator and the second fraction, and there's a 2 that's common in the denominator of the second fraction. Okay, and then this is the fun part. Those divide out, they're exactly the same. These divide out, they're exactly the same. these divide out, they're exactly the same. So you're left with just a 1, because these are all 1s when you divide them out. So you're left with a 1 in the numerator and 2 in the denominator. In terms of your restrictions, Z, sorry. So Z cannot equal, you go back to the factored form. If you looked at this, you'd say there's no restrictions. So here you look, that would be 5 over 2, opposite sign, divide by the coefficient. This would be 4, and this would be negative 5 over 2. Okay. And then the last is dividing. So 8 is any of those. So I'm going to choose C. Lots to do in that. So C, that's a difference of squares. So that'll be 3x plus 1 times 3x minus 1. X plus 5, nothing to do. Now, when you're dividing, remember it's just like normal fractions. You invert the divisor and multiply. So this becomes a multiplication, and then the 2 minus x goes in the numerator, and then the denominator has to be factored. Okay, so again here I'm looking for two numbers that multiply to negative 6 and add to negative 5. And then it's going to be 3x and x. Again, you can use decomposition, whatever. There's a bunch of methods to use. This is how I like to do it. So it's kind of the first steps of decomposition, and then it's trial and error by thinking about expanding. So working backwards. So that's going to be negative 6 and positive 1 that I have to get. So negative 6 would have to be negative 2 and then positive 1. And I always expand back to check. So 3x squared minus 6x plus 1x is negative 5x minus 2. Okay, so some things that I can divide out. So the 3x plus 1s, okay, and then this is close, okay, not quite, because that's a positive 2, and that's a negative 2. So I'm going to do this in 2 steps. So really I've got my 3x minus 1, and now I'm going to factor out a negative 1 from this. So that's going to be x minus 2. You can show it as a factor of negative 1. You can put a negative out front of the first bracket. Just don't put a negative between them, because then it looks like subtraction. Okay, and now I can divide those out. And so my final is going to be negative bracket 3x minus 1 over x plus 5. Again, you can keep brackets in the denominator. You can keep that out front, up top, or out front. Just make sure it's in brackets if it's up top like this. Then your restrictions, go back to your factored form. So we have to look at a few places here. The first denominator, so x can't equal negative 5. We then have to look back here to the second denominator. Okay, so x can't be 2. Then we have to look at the denominator once we've flipped it. So really you're looking at the first denominator and both of these for restrictions. But you look at the factored form. So then here, x can't be negative 1/3, x can't be 2. We've already got the 2. Okay. So that's a dividing question. So that's simplifying, multiplying, and dividing. And then I'll put another video up in a bit for adding and subtracting.